Last time I promised to explain what CNCF landscape is, and I will do it, plus we have another interview. So, CNCF landscape, you can find it under the link landscape.cncf.io, kind of obvious link. And what it is, it's a curated list of tools. Some of them are under CNCF already, in different stages of life. Some of them are proposed by CNCF team in different categories, in different, we can say, layers. It can be like tools like Kubernetes itself, it can be tools for IIC, it can be tools for security, for delivering the application to the cluster or whatever. So we can have tools like Terraform, like Kubernetes, I said, Istio, Argo CD, and many more on this list. So you can go there, select the tools you want to use and play with them. Of course, all of them must be open source because this is CNCF, right? And of course, all of them must be related to the cloud because, again, it is CNCF. And now, I think that's enough explanation for CNCF landscape itself. We can go to the interview. It's fourth interview from 6 I did during the Kubecon in Paris, and I know there was a gap between the last one and this one, but well, it happens. So this time I talk with Matt Ray from OpenCost. We talk about community, we talk about OpenCost, of course, we talk about Kubecon, we talk about, I think, many things. And this interview is only one from these 6 where I had the opportunity to record in quite silent place. So enjoy, because spoiler alert, 6th one will be terrible in terms of the noise. So enjoy. So now I am in some quiet place finally with Matt from OpenCost. So thank you very much for your time.
My pleasure.
And let's talk a little bit first about Kubecon itself. It's third day, last day finally.
Finally, it's been a long week.
Yeah, definitely. And a lot of people. I heard that about 12,000 people is here. So it's really huge.
Really big, really big
number. Yeah. And how it is going for you so far?
It's been great. We started the week Tuesday. They had lightning talks from the various projects that are in the sandbox, and it was kind of funny. It was first time I've had a talk interrupted with applause in quite a while.
Oh,
yeah. So
that's good.
We had some announcements this week. We announced that OpenCost is now supporting carbon costs. So being able to tie the cost of your infrastructure to Kubernetes is one thing, but being able to give you the carbon cost of your namespace or your applications, that was what was kind of exciting for folks. Yeah.
That is really cool thing. I was at EPAM that time where we thought about something similar, but it was more like a concept.
Yeah.
And
it's been kind of hard getting to this point because the cloud providers in general, they'll give you the level, your carbon usage at like the data center level. Like, if you're on AWS, your EC2 usage is this much, but you've got some ARM instances, you've got some Intel, you've got some larges, some smalls. You can't break it down. But we've been working with another open source project called the Cloud Carbon Footprint Project, and they finally got like the node level, so we can actually tell you like these nodes are good, these nodes are bad.
That's really cool, and I'd like to see it in action because it's something. It's not only the climate changes which are very important, but the understanding of it is just important because it's quite important for our lives and for our kids, I think.
Yeah, we live here.
Exactly. So I'm sure that we will not go into the details, but in terms of Kubernetes, I think that was kind of tough to find a way how to properly manage the cost and find the cost for the pods, how they scale, how they operate, right?
Yeah, and so that's where OpenCost got started. Was focused on the cost of Kubernetes, and whether it's AWS or Azure, GCP or on-prem. And then late last year, we announced we've started parsing your actual billing. So if you're on AWS, we're going to read your cost and usage report, which usually gets published 24, 48 hours later into an S3 bucket, and it's massive file that you got to parse through. But we have started parsing that and exposing the contents via an API. And hopefully eventually we'll be able to tie that back to Kubernetes. But for now, we have an open source way to read your bill, which is supported and maintained. And that's a big milestone, just having access to that. And so we have cloud cost, carbon cost, Kubernetes cost. And then the other thing we announced is we now have a external plugin costs. And so you're going to be able to bring in the cost of like a SaaS you might be using, or, a SaaS is the easiest example. And so our reference implementation is Datadog. So if you wanted to see the cost of your Datadog, we pull down their bill, parse it out, show it to you, put it behind an API, and then you could, eventually we'll be able to say like, well, here's the Datadog cost of that namespace or that application.
And I have like a crazy idea in my mind. I was spent a lot of years being on call, and I have this picture in my mind that I am wake up at 3 a.m. having the alert that my carbon cost is too high. That will be
nice when it switches off of solar. So yeah.
Yes, yes, that's true. I wonder, because this you'll become more and more granular with cost here, right? To understand better what we are doing. Do you see any reason, any like a logical reason to go even further and provide the cost by, I don't know, API request or time of the execution?
That would be a lot more intrusive into the code base, but I could definitely see if someone wanted to do an external plugin. The whole point of the plugin architecture is to bring in some new costs, and so it might be. As long as we're talking hypothetical, you might write one for your application where you send those numbers back into the system to be able to correlate them next to each other and run queries together. A lot of times people take our data and export it to other systems where they're doing that sort of stuff. So OpenCost is embedded in solutions from Kubecon, who's my employer, but also we're embedded in like Azure's cost analysis portal, and we're embedded in Grafana's Kubernetes monitoring. So if you were, and we export our data through Prometheus, through APIs, through CSV, through Parquet, we're making all this data available, so you could easily, if you had some sort of dashboard where you're tracking your access, your request, and you could put them on the same graph as pricing, or even narrow it down to which machines have the longest requests and how much do those cost. We have that data. I don't think it's going to come from OpenCost, but that's the sort of use case that we want to enable. Is right. We want to be that data source where you can put that the cost monitoring next to anything.
Yeah, so not always what is possible is really smart to do, right? So there are other approaches, other ways to collect this data. Maybe a little bit complicated, in comparison to doing this like just simple way, but still gives you, I think, still more context around, because it's not only about the request, right?
Yeah,
So that's why this kind of crazy idea in my mind to ask you about this, because this is something what can come as a next idea, right? But it's not necessarily smart move.
I mean, as long as we're like talking hypotheticals, OpenCost doesn't do network traffic, but other solutions built on top of OpenCost like Kubecon do. And they're looking at like contract, IP contract, and seeing the connections coming in and out of containers and tracking that sort of data. You could easily do API requests the same way. So yes, it's not that big a stretch to actually do that. It's just it would be very specific to each application. But if you're a large service provider, if you are a SaaS or something like that, and you had this embedded, you would be able to track that sort of thing together. And I think that's really compelling.
Yeah, that's true. And I wonder from another hypothetical situation, or maybe not hypothetical. I am very deeply engaged in the CI/CD stuff and things like that. And I wonder, because very often in DevOps world, we focus very much about delivered application, control this application, monitor it,
Right.
and so on. But and secure it, of course.
Yeah.
Of course, I'm not sure.
Hopefully.
But we always, maybe not always, but very often forget about this part which delivers it, about CI/CD, right? So we start to think, there should be some security, right? But right now I think, do you see the movement like, we should control the cost of CI/CD?
Yes, definitely. There's kind of two aspects there. One is you definitely want to monitor how much your CI/CD costs, right? And look for opportunities to save money there, whether it's like spot instances or moving to ARM or something like that. Those are the sorts of decisions we want to enable by providing the monitoring data. And then the other thing that we don't do yet, but has some other solutions have built built this on top of OpenCost is predictive costs, where when you're doing your CI/CD, maybe you would say, I'm about to deploy this application and it's going to go across 14 pods. How much is that going to cost? And then, well, how much would it cost if I put it on Azure versus AWS or GCP or wherever? We don't do that yet, but that's something that's been requested. It's come up in conversation repeatedly, and so I could totally see inside of CI/CD, a cost gate.
Yes, yeah. exactly, and depends on for example, environment. You can decide
exactly
you are good to go or not, right?
Because what we can tell you today is how much does that application cost as it's currently running. And so it's not that big a stretch to say, well, what if I do it again? I have that number. What if I do it somewhere else? I could kind of get that number. But that's something we would love to see in the open source community. If you have an itch to scratch, we want to host that.
Yeah, that's perfect. I wonder about this estimation, the cost estimation, because having the information about costs of something what is running is relatively simply. It is running, so it costs something already. You can collect this data, right?
Yeah.
With estimation is a little bit harder. Because,
it's really hard.
Yes, that's true. Because it depends really how people approach to the problems. Because we can say that, all right, so right now you said that it will probably cost $10 and it costs really $100 or $1,000. But the data you provide for the estimation tool is not necessarily what you do really after that.
Well, with Kubernetes though, a lot of when we calculate the cost of a pod or a deployment or something like that, the way we actually have an OpenCost specification that lays out how costs are calculated. But the first thing we're looking at is the request and limits on your containers. And so if you have set those, you are actually have a very good idea what you're going to get. And then it becomes a question of, well, what are you deploying it to? Are you going to a T1 micro or a MX triple XL? That will be different. So then it becomes but we can just look at those prices up. So we can tell you relatively like what your application is going to look like. We're going to know how many containers are going to be running. We know, assuming you filled out requests and limits, we know the size of those things. And so the estimate gets better the more effort you put into it. And then I believe like Kubecost's prediction API, you do say where it's going to go, what kind of node, and which provider. So you can get closer and closer the farther you go. And then what would be interesting on top of that is things like spot prices. Things are going to get they're going to change over time a lot. And carbon costs. Carbon costs actually are not static. They're changing during the day depending on the source of your electricity provider.
Yes, that's correct. And this is also kind of hard to estimate, right? Because
Yeah.
you have to know exactly where this workload will be executed.
Yes.
To
Yeah.
calculate.
Well, and in that case, we're dependent on the data provided by the cloud providers, and
Yeah.
so the quality of that data is up to the cloud provider. So we're providing estimates on top of estimates, but it's better than nothing.
Of course. That's, at least it gives you the idea what may happen. Right?
Yes.
I wonder, because today every company is AI company, right?
Yeah.
Do you see any potential in building some models
Yes.
exactly for?
Yeah. So that Kubecon, for example, is building machine learning models on top of this data. Right. So OpenCost is the open source engine for Kubecon, and Kubecon is the primary maintainer of the project. But Azure has a maintainer, and there are other community maintainers, but they're doing a lot of the effort, and they're taking this monitoring data. And one of the tools they have is actually predictive pricing. Hey, what are my costs going to look like projected out a month? And they have that sort of tooling. There are other folks doing similar work in the space. I'm going to let them make their own announcements, but yeah, that's definitely a common use case. Is like, let's use some ML to pattern out what our costs are going to be going forward, and then. You could get even more ambitious and say, well, maybe I'll let an AI-driven autoscaler start to move things around based off of cost, or reallocate things. I mean, because today we already have autoscalers that are cost-based.
Yes.
That they will move things and resize your clusters, like with Carpenter, move them to spot instances. So it's not it's quite understandable that someone would build that sort of tooling on top of it. But the good thing is they can do that. OpenCost is focused on monitoring.
All right.
We're here to give you good data.
All right, that's perfect. And now, if you thought that was hard topic, now it will be hard topic, because this is about tool.
Yeah.
And using the tool. But how do you think how to enforce and improve the knowledge and the approach of the community of engineers to better understanding the reasons and the values in having something like that in their daily work, really?
Yeah.
Because this is something what we quite often forget, really, right? So we know this, we have this code, we know this tool, we know that tool, and we just run it, and it's run, it's fine. But what next? How to teach people that there are tools around which are designed not just only for earning money. Of course, everyone wants to earn money.
Yes.
We want to eat something. But there are tools really which can help you to better understand your landscape.
Right. I mean, part of that awareness and understanding of what's going on is we're very involved in the FinOps Foundation. It's another foundation next to the CNCF inside the Linux Foundation that's focused on cloud costs. From both an accounting and the business side of things, but also the engineering. And so we're very engaged with that project and working through their education and training materials to make sure that when people start coming from the business side, they understand what's going on inside their applications, and coming from the engineering side, understanding why these things are important to the business. And so we're involved in the FinOps Foundation and their efforts to drive standards. We have our own documentation and training. I'm working with the Linux Foundation on getting some OpenCost training available. So it's really just a matter of trying to get people to use the tool and then understand why this is important to them. The good thing is money is important to most people. So literally everyone has a financial reason to care about this stuff, and we just want to make that data available so you can make the decisions you need to.
And I see, in my past career when I was the SysOp and I was focused on finance part only in the terms that I want the more newer, more powerful servers, and I don't care about money behind that. Right?
Yeah.
And there's FinOps Foundation, and it's great that you mention it. It makes the shift. Again, I don't want to say shift left, but somehow it is shift left in the mentality and the mindset about the costs to not only to this finance department, which all of engineers hate, but to them really to make sure that they somehow own this, right? So if you treat something like almost your own money, probably you will care more about this. I hope at least.
Definitely. Well, I mean, if people could be incented by the amount they save, they just turn everything off. But
oh yes,
yeah. The nice thing is a lot of times there's a strong correlation between improved Kubernetes efficiency and improved Kubernetes cost efficiency. So knowing that your application is running across a dozen nodes in a cluster, well, maybe you could be using a smaller number of nodes but larger ones, and rather than have 12, you have 3. It might be cheaper still, and because they're co-located, you might get better performance out of them, and they're less likely to have noisy neighbors, and so they're going to have better, more of the physical node that they're running on available to them, and so. We do not do recommendations, but when we start talking about ways to improve your efficiency, that's a frequent solution, as well as looking at alternate architectures. ARM is a lot cheaper than Intel, and actually AMD is cheaper than Intel sometimes, and so that is the sort of optimizations you can make that it's going to make your Kubernetes better, and it's going to make your billing better.
Yeah. Now, I have a scenario in mind. For example, we all know that for Black Fridays, this is like nightmare for engineering teams, and especially for ops teams.
Yeah.
And I see very nice case when I can use the knowledge about the costs correlated with knowledge about the performance of my application and how many requests I was able to serve or how many requests was rejected because of my not optimized approach, and I can calculate even a little bit better probably how should I scale in terms of having this kind of peaks, because this is, well, to be honest, there is one company in Poland, I will not say the name, that they are always, every single year, they are surprised by Black Friday. I don't know how it works, but for them it works somehow. Possibly one of the reasons is the cost of the scaling, but how we approach to the scaling in these terms, we just scale in relation to what we learned last year, and we just jump. Because in most cases, it is like pre-scheduled scaling. It's not scaling with manual. The traffic, right? So having the proper costs or the estimation what we will have, can help us to properly manage this scaling, even if this is manual process. I think, at least.
Yeah, I mean, there's year to year, there are just amazing improvements in the quality of the autoscalers, and so. I mean, one of the things that we're kind of excited about is the Carpenter project, which has the concept of auto-scaling out to spot instances, and we've seen pretty good success with that. And OpenCost isn't directly integrated into it, but I could most of the autoscalers work quite well. And whether it's the vertical or horizontal, and so hopefully this company in Poland will, hook up a little bit of intelligence to watching their traffic, and when they get to a certain amount of overhead is missing, they start adding more nodes, because that's the sort of use case that those tools are there to serve, and hopefully we don't talk about them next year.
Yes, I hope so.
And whatever sales they have, you get what you need.
Well, I'm not using them, fortunately for me. I prefer other brands. Well,
sure.
Well, it is what it is. Okay, thank you very much, Matt, for your time. It was great to talk with you. The last question I have, what is in your mind, what is the next step for OpenCost?
For OpenCost? Well, right now we're really focused on kind of three things. One, we just announced this carbon cost. It's going to need a lot of documentation and training, and educating people about what to do with this data. We also we're announcing our new plugin architecture. We have a reference implementation, but we're going to need good developer documentation so people can implement their own. So they can bring in new data sources to correlate costs. And then the third thing is the OpenCost project is it's a sandbox project. We've applied for incubation. We're moving forward, and hopefully we'll be announcing that we've moved into incubation soon.
Right. Thank you, Matt, very much.
Thank you.
It was a pleasure to talk with you, and please try OpenCost because this is something what you need, even if you don't know. So again, thank you very much for your time, and enjoy the rest of the event.
Yep.
It's only a couple of hours.
Couple hours left.
Thank you.
Yep.
It was the interview with Matt from OpenCost. Next time, I will not have any explanation. It will be just the interview and my introduction to it, because I think I already said everything what I wanted to say about CNCF, I think. So next time we will meet with Corey from MassDriver, and we will talk about infrastructure as code. We will talk about Kubecon. We will talk about community. We will talk about open source. We will talk about many other things. And again, please remember that that interview was recorded when I was at Spacelift. I'm not there anymore right now. Thank you very much, and see you next time.